Perfect. Well, thank you very much for your time today. I'm going to be introducing several of our flood resilient homes. Some of them have just recently been completed, but also some of the new projects that we also have on our books as well. So this is a slide which puts flooding into context. What we've done is we've pulled together all of the information that's available from the EA, mapped onto that some of the maps, but also some of the information from the GLA. And what's interesting, all of the areas in red, obviously associated more or less to river courses, but more so their likelihood of surface water flooding, not just flooding from rivers. And then that's sort of indexed again against the insurance sector. So these are areas in the future where there's a nice debate between the government and the insurance sector whether to maintain flood insurance for properties. And in the event of those places flooding, what we might do as architects or urban designers to deal or to mitigate that flood risk. So we've been involved with some flood research called the LIFE project, which stands for Long-Term Initiatives for Flood Risk Environments. And that was commissioned by DEFRA almost 3.5 years ago to look at ways to make space for water in a predetermined fashion. Currently to date, in Europe, the solution has been to build flood barriers to hold out water. But as we know, Mother Nature will prevail. And as you can see in our diagram now, which this is the diagram we use in euros, but we have the same in yen and different currency, because it's a familiar cartoon that sort of made its way around the world. But it sums up things nicely. Is how much money are we prepared to keep building flood defences without possibly a more intelligent solution? We've just recently drafted a new chapter for the Metric Handbook. For those of you that don't know this publication, it's an industry guidance that whether you're a student or a well sort of seasoned practitioner, it's your reference guide. And over the last sort of year or so, they've been refreshing that, and they've started to introduce aspects of climate change. And we've authored the section on flood risk. And that's part of the essentials section. And what we have here are, in a very simple diagrammatic form, if you're an architect and through landscape design we can't design out water, what are the potential solutions from an architectural typology to resolve this? So starting on the left, we have raised property. Now, that seems quite a common sense approach, but the Environment Agency, if you do this, like to see like-for-like compensation. So on large areas, realistically, this is not a viable solution. The resistant and resilient, we can start to hold out water. So this is for low levels of flooding, sort of knee height, which will happen infrequently. And we can use things like flood guards to hold out the water. Other options are elevated properties, which again is a very sensible solution. But what we're finding in certain circumstances where, especially along the River Thames, where people have restrictive covenants for ridge heights, and equally the Environment Agency are asking for flood levels to be above a certain level, we're finding you're getting left a build zone of 1.5 metres. So even the shortest people can't live comfortably within that area. But equally, it creates a dislocation from the garden. So if you're above 1 story, we sort of say, well, is that the right solution in terms of qualitative nature for the urban environment and activating the street scene? The amphibious property is a really nice balance because it allows the property to sit on the ground, and in the event of a flood, and that might only happen once in your lifetime, it can lift the building. And the one we're going to talk about shortly is the amphibious house in Buckinghamshire. And then floating properties. And again, that's another version of the amphibious, but these tend to be in bodies of water. And obviously, if you're a landowner, you need to own that stretch of the river or have licenses with the Environment Agency. So today we're just going to talk briefly about the amphibious house. This is a site over in Buckinghamshire. We've got a laser? No, okay. The river runs in this direction. Our site is somewhere in this location. We have a weir to the northwest, and as you'll see, the site is wholly within flood zone 3B, functional floodplain. So if you were a landowner and you want to build a brand new house in this area, the Environment Agency will say, no, it's only for replacement dwellings. There's a quick view of the site. And these are, in terms of trying to generate an amphibious house, these are some of the key issues we had to deal with. It was located within a conservation area. It was PPS 25 at the time. There was no planning precedent for this building typology, so that was quite a challenge to convince the planning authority to allow this sort of building to come forward. With the Environment Agency, equally as well, no precedent. So we had to work with our colleagues in the USA and the Netherlands to provide the case studies and the necessary data to prove that this was a safe technology. And then again, building regs. And currently at the moment, we have a bid which was in with Innovate UK to start to fill that vacuum in terms of building regulations. Because if you're a designer, you say, well, what standards should I be designing to? So we've kind of tested that for our industry. And, as a result of that, we explained to our client that we would have to be doing this to a very high standard because our building in the future will become the benchmark for these regulations. So the diagram that we have on the left-hand side shows you the flood level in a 1 in 100 year flood event plus climate change plus 300 mil freeboard. And what you can see there is, had we built or raised the first floor to that, or the ground floor to that level, we get a build zone of about a single story. The benefit of the amphibious house means that we can maintain the ground floor at a constant distance from the flood level. We can use the displacement within the basement through Archimedes' principle to gain an additional level of accommodation, and also squeeze in an additional floor within the roof space. So this is just a section through the site. The building doesn't become buoyant through overtopping. It's actually got a permeable base, and the water raises through the groundscape. So it becomes buoyant through Archimedes' principle, and what you can see here, this is the equivalent of Rolls-Royces. So it's lifting a very heavy weight, and the reason why this building is designed specifically heavy is we have to anticipate debris within the watercourse. So it's if it picks up a canal boat or it picks up a car and it bumps into our building, then it can withstand that. And that's some of the benefits of this technology over some of the more lightweight floating houses. So it's always very important to make sure you design your house specifically for the flood conditions. So this is some of the building will become buoyant when there's about just under 2 meters within the wet dock. And this just is some of the construction. So the way that the building's constructed, we have outer perimeter wet dock, which you can see the sheet piling. Within that, we have a can float foundation, which is a waterproof concrete displacement unit. Here you can see it just before the first flood test. These are called dolphins, so this is what holds the building in place, and behind that there's a little bit of magic which keeps the building true and level. You can see Matthew, our engineer, and myself on site, just as we're about to pump the water in. And in the first flood test, we just raised the building about 1/2 metre, and that was to make sure that the can float base hadn't stuck to the bottom of the wet dock. And equally to make sure actually the casting of the concrete was uniform, and there was a little bit of ballast we needed to do to bring that true and level. The second test we did was actually once we had the structural frame on and also the client's furniture inside. So the way that this building is designed is we anticipate in the same way that you have your car and you do an MOT every year, that the occupant has to demonstrate in the same way that if you owned a boat, that all of the mechanisms and the slide gear will work. So this is just the footage. You can see it's AstroTurf there just with the Grand Designs show and just some of the key images. So this was just still under the final phases of construction. So the client has now moved into the property. So what you can see here as well as architects, whilst we're doing the practicality or the pragmatics of flood risk, it's very important that we bring all that together, and it's actually very beautiful. And going back to the chairperson's initial question, does this technology cost more money? Well, if you go for a standard house in London with a basement, you're looking for about 10-15% uplift in terms of the cost over just ground floor and above. So the basement is broadly that same price with just a marginal uplift for the wet dock capability. Now, what's interesting on this site is now our client has the ability to maintain flood insurance. There's a number of the properties on the site that have been flooded. It's taken over a year for their houses to recover and to be maintained. So in the round, you've got a house which has some of the best views in London. You have the safe knowledge that the house is wet and dry and flood resilient. And as I say, you get to see some of the most panoramic views over London. And the only concession is that you have to just invite Kevin around occasionally to just ask you how much it really did cost. So possibly a good time to hand over to the next speaker. Thank you very much for your time.
Archetype is an architectural practice specialising in sustainable design and passive house in particular, working across many sectors. But our purpose as architects is really to design life-enhancing, genuinely sustainable architecture. We're not interested in greenwash, but in doing things really effectively. So just a couple of examples of our work before I get on to our approach to housing. This is a school in Wolverhampton, the first BREEAM Excellent primary school in the UK. And you can see not only energy efficiency, but a very high quality of material spec and environmental performance. This is the UK's first co-housing scheme, developed by the people who actually live on the site, and again built to very high energy standards and a different approach to organisation, with cars kept off the site and communal shared gardens within which the individual houses are set. So as architects passionate about design quality and about sustainability, we've been increasingly frustrated with the quality of housing, particularly in rural areas where one of our offices is based. And we formed a new company called Archihouse in order to address this issue. And our purpose really is to attempt to transform the quality and sustainability of UK housing, which is obviously a big ambition. And we're starting off with one scheme and a plan to try and do that. The challenge that we're responding to really is the fact that much housing in the UK, we think, is of fairly poor design quality, is generally constructed to minimal and very poor energy standards. And in rural areas, many of the sites seem to be very suburban and sort of inappropriate to their setting that developers are currently doing. And these are some of the typical developments in and around Herefordshire, where our West Office is based. And we think we can do much better than this. But the other thing we're trying to respond to is the other end of the sort of extreme housing provision, which is the whole zero carbon agenda and code for sustainable homes, which has led to high-tech add-on renewables, which we think also is not the right way forward. It's expensive, and it's been found in many ways not to work. And the reason why I think it doesn't work is that I think the very idea of individual houses each having to be zero carbon is a fundamentally flawed idea, because it's based on offsetting carbon rather than saving energy. And because of that, it requires people to use building-based renewables, whether or not they're going to work or the appropriate thing to do, or whether or not they're efficient and economic. And actually, it has tended to encourage buildings, or it's allowed people to get away with buildings which are less efficient than they should be, rather than encouraging better efficiency in fabric first. So our vision is to respond to that and just do Passive House as standard, and get heating costs for houses down to as little as 50 quid a year, to develop a quality assured design and construction process which guarantees better standard, but is still maintaining affordability, i.e. we're not looking at the high-end market, we're trying to compete with developers, but just do it better. So first of all, what is Passive House? Well, I think everybody knows that it's a rigorous energy standard, but I think it's really important also to understand that it's a rigorous comfort standard. It's about getting the best possible comfort in a house for the least energy. But really importantly, it's also evidence-based. It's actually based on what actually works, monitored over a long period of time. And it's also a quality assurance standard, which guarantees that if you follow the design and construction process through to certification, the buildings really will perform as intended. So just a very simple illustration of Passive House. Two ways of keeping coffee warm. On the left-hand side, a well-sealed thermos flask. On the right-hand side, a filter system which requires constant energy to keep the coffee warm, as you can see in this thermal imaging camera. And Passive House really is that, the left-hand thermos flask. And actually, after a few hours, the right-hand coffee will taste pretty disgusting as well. So Passive House was developed in Germany 20 plus years ago in response to people realizing that buildings weren't performing as they should. And a standard was developed and is now administered by an institute. The basics of Passive House, I won't go into any great detail, but they're all about getting the orientation and the form of the building working together with its setting and its environment, improving the building fabric substantially, better insulation, better airtightness, better window spec, reduced thermal bridging, using mechanical ventilation with heat recovery in winter to guarantee good air quality without losing heat through natural ventilation, although you can open the windows if you want to, and then using PHPP in order to model and optimize design to achieve the very rigorous energy target. So in essence, in the UK, what we tend to do is allow our buildings to use energy that they shouldn't be using, and then try and offset that by plugging in lots of renewables. But I think it's daft to be having renewable energy if you're just using too much energy in the first place. Much better to first of all save energy, use less, and then think about renewables afterwards. So in Passive House, you improve everything about the design of the construction in order to drive down energy consumption to hardly anything at all. So at Archetype, we've always believed in using the design and the construction to be sustainable and to save energy. So we adopted Passive House quite a number of years ago now as a really rigorous way of delivering this. And we, about 3 or 4 years ago now, we finished the first UK's Passive House schools, 2 of them in Wolverhampton. And so these have been up and running, and we've been monitoring those over recent years. And we've now on to our 5th Passive House school. And just to give you some idea of the monitoring of the energy consumption, on the left-hand side, we've got typical benchmarks established by CIBSE. Our BREEAM schools achieve this sort of level of performance. Our Passive House schools are getting right down here, so about a 90% reduction in energy compared to industry standards, and many actual new schools are performing much, much worse than that. So monitored, actual, definite proof that it works. More recently, we finished the UK's first archive building to Passive House, and we're just on site, almost finished, with the UK's first university building to Passive House. In terms of housing, last year we finished one of the largest residential schemes in the UK to Passive House at Chester Belmore in Camden, and we're also involved with 1 or 2 other housing developments around the country to similar standards. And here is just an example of some of the monitoring that's been done off Passive House. So on the right-hand side here, 3 Passive House schemes in Germany monitored. Each bar is an individual house. So obviously performance varies between houses, but the average performance across all 3 schemes is coming in well under the Passive House level. Whereas on the German low energy standard, which is way, way better than UK building regs, even the very, very worst performing Passive House, where the guy must have the windows open, heating on all day long, is still better than the very worst, or the very best of the low energy, and that goes right up to an average of 66 kilowatt hours compared to the 13 and 14 for the Passive House. So more proof that it actually works. So our strategy in Archie House is really to deliver Passive House to a better design standard and at an affordable price, is to rethink everything. To rethink the design of the house from first principles, because we know that if we just take houses that are already designed and try and adapt them, it won't work. So we want to rethink the design of the house. We want to rethink the design of the site to make it efficient and work to Passive House, as well as being more appropriate, in this case, to the rural setting. And we want to rethink the process of construction to move away from the typical on-site, rather laborious UK approach to off-site factory production. So I'm just going to take you through how we've developed these principles in our first scheme. So we managed to buy an option on a piece of land of about 20 acres in a village just southwest of Hereford City, and went through a process of community consultation and planning application in order to obtain planning permission for what we've now achieved, a scheme of 150 houses. So this is the site contained within the village. So it's a big expansion within an existing village. And this is the layout that we developed. It's about half the density of a typical developer scheme in this area. But as you'll see, the houses are laid out to be orientated within 15 degrees of south, which at one level makes a more rigid layout, but another level makes, with a low density, makes far more connection into the wider and very beautiful landscape that we've got. Better views out, better views in to the site, a much greener overall approach. And then we've organised the houses around typical rural lanes with shared surfaces, so people, bicycles, cars all share very simple windy lanes. And because they're windy, nobody can go very fast on them, and it's a very safe way to do that. And then we're dealing with our drainage entirely through sustainable urban drainage with swales and ditches and soakaway areas. So you get biodiversity as well as good drainage. And then we're doing all the boundaries between areas using traditional local native hedgerows, so that together we're creating almost a microcosm of the beautiful Herefordshire landscape within our low density site layout, but then ensuring that all our houses are efficiently orientated to maximise their solar benefit. So here's just a view of a lane winding through. You can see the swales, ditches, hedgerows and the houses sitting within the landscape. And then within our overall site, we're creating quite generous outdoor green spaces with a new north-south swathe parkland with a cycle footpath connecting the two parts of the village, with opportunities for natural outdoor play, with community allotments and orchards. And this is another view of the scheme, very different to most of those typical developer schemes that I showed earlier, very much in tune with the rural setting. And in terms of the design of the house, we started off with our passive house analysis because we wanted the shape and the form to influence our design to make sure that what we were designing was efficient from a cost point of view. And what we discovered was that if you take the typical developer house, which tends to be narrow frontage with a deep plan, and turned it around so that it has a wider frontage and a shallower plan, it works much better for passive house because you've got a better orientation to the south. Whereas on the typical plan, you have a narrow hallway to connect the back and the front of the house together. And if the front faces south, the back living room will face the north. With a sideways plan, both the main living room and the dining kitchen can face to the south and to the garden, and upstairs both the main bedrooms in this 3-bedroom house can do the same. So you end up not only with a house which just inherently is more efficient by its footprint and its design and its form, but it actually works better in terms of its design construction, and you're getting the heating costs down from typical more than £500 a year to less than 100. And you can see here in the layout, we're not talking about creating big mansions, we're talking about normal developer-sized, modest houses. But because of this approach to layout, we can create a more generous feel, a more open plan, flexible arrangement because of this sort of sideways arrangement, and a more contemporary feel. So we're trying to, in a sense, capture a little bit of the grand designs that everybody aspires to, but actually make it affordable to people as well as energy efficient. And going from very, very simple, well-proportioned rooms, well-considered window openings, all very, very straightforward but simple principles of good design. We're avoiding all the things that developers tend to add to their houses, like fancy dormers and little twiddly bits and pieces, and actually spending the money on simple, good principles design, better insulation and efficiency. And in terms of the overall form of the house, again, we're keeping that very simple. We're keeping the eaves quite low, a very traditional rural sort of form, opening up the roof slope to the full height to give more sense of space and volume, as well as creating opportunities for storage and sleeping bed platforms. So what we're trying to do here is apply the principles of thoughtful, well-developed, integrated, sustainable design and apply it to sort of mainstream housing market. We managed to now obtain planning permission for this scheme, despite it being a big site outside current policy in a rural area. And we're now in the process of setting up small-scale workshop factory production and raise finance to actually put this scheme onto site, which we're hoping to do by early this time next year. So in summary, what we're trying to achieve here, and we're well on the way now to delivering, is sustainable, high-quality design of housing and of landscape integrated together, spacious, efficient, passive house buildings by design at an affordable price, but at the same time trying to integrate development within the existing community. And already we're finding huge interest from potential purchasers wanting to come and live on this site. And as I said, we're just in the process of gearing up. We're doing our first prototype at the moment for factory production and creating local employment. So I think what I've hopefully got over today is that by having a vision of a different and better way of doing it, and using that vision to drive everything we do in terms of design, cost and efficiency of energy efficiency, we can actually start achieving things which developers with their existing models of housing development aren't really able to respond to. So it's thinking outside the box to deliver something which I hope will be much better. Okay, thank you.
My name is Nout Paas, a very Dutch name, from Paul de Ruiter Architects from Amsterdam in Holland. I have to give you a small warning up front. It's not so much about housing, but more about our approach to innovation architecture and more healthy and energy efficient buildings. The office started about 20 years ago, and it's about the thesis was the chameleon skin. How can buildings behave more like a chameleon, so be more adaptive to its surroundings, to thermal surroundings, air, and so on, the soil. By that time, energy efficiency and healthy buildings were not so much a theme, but during the period the office has existed, it's become more and more important, and now we are seeing on the whole scale of different kind of projects that we can implement these ideas. I'm going to show some quick projects and then elaborate more on one project I think is very interesting. It's a school in Holland. This is our own office. In Amsterdam, the ground is quite scarce. So what we did here is we bought this welding hall and we transformed it into our own office. So this is now our office. We as a developer together with a movie company who produce Dutch movies. This is a project I would like to show. It's a housing project in Amsterdam in North. It's a tower. Here we've been searching for a way to make also a kind of passive house solutions in a tower volume. So what we're doing here, we're making outdoor spaces which you can close off and you can capture the heat of the sun during the summer, during the winter, and during the summer you can use it to ventilate the building volume. And it is kind of it shows also its sustainability and can be a landmark in Amsterdam. We've been now starting the groundwork for this project. The windmills are a bit optimistic perhaps, but we like them. We're also doing a lot of educational buildings. This is a building for the Rotterdam University, Rotterdam Business School. And here we've been looking for ways to deal with a very transparent building. They wanted to show more inside the building what's going on there. And but when you make a very transparent building, you also have to deal with sun heat and the negative effects of this. So what we've been looking for here is how you can deal with kind of a texture on the facade, which are deep lamellas that have a different depth on each facade. It's now almost finished. It's become a very beautiful building, and also its energy performance is looking quite promising. This is a project. This is it's called the Afsluitdijk. It's a big dike in the north of Holland. Raising waters, as we heard in the first talk, is also a big problem in Holland. We're dealing with a raise in 50 centimeters the coming decennia of the ocean waters, and our dike is not really up to date anymore. So we're now working on a master plan on how can you do the renovations of the dike smarter than only throwing up a new layer of stones, and also the update of the water the water spills. For us, architecture is not so much about aesthetics only, and maybe architects have a tendency to pull on this point if the green is your budget for a project. But we think especially health, CO2 emissions, innovation are quite important for us. So we're always trying to not approach the typical architectural points, but try to focus on health and emissions. This is a house we've just finished recently in Holland. It's fully self-sufficient, which is really important, interesting. The owner has a big plot of land, which he has developed into a landscape. Here you can see also the water party here. Under it is a underground space for his cars, and here is a small office underground. The water kind of cools the underground spaces, and then you have this connecting element, and above ground you have a really big transparent house with a fantastic view of the surroundings. Of course, when you make this amount of glass, you also have to deal with the heat load of the sun. What we did is we made a quite efficient climate facade, where you have a sun-reflecting fabric coming down, In summertime, it's really, really opaque, so you can look quite well through. And when the sun is too hot, you can kind of capture the sun heat between the glass and the fabric. It's pulled up, and then you can reuse the heat in the heat storage, which is in the soil, and you can use it in the winter again to heat the building. So I think these systems are also well known in the UK. So this is kind of a section of the building. We use the whole roof for PV paneling to get the energy for the electric use of the building. And we're now looking for the biomass installation from the surrounding woods, that he can even deliver energy back to the surroundings. We're working a lot with BREEAM. BREEAM has become kind of the Dutch standard too now, so that's also interesting from UK point of view. This is a building for Fluor, which we did. It's an American engineering company. Here we've been looking at how can you make in a kind of corporate surrounding still a very energy efficient building, but also to make sure that they don't close off the blinds. And so what you see in a lot of offices, you make a lot of transparency, but then they close the blinds to prevent glare. So here with computer modeling, we've been able to design a quite simple element, which is based on a kind of grill-like element with lamellas inside that are orientated towards the strongest sun to get daylight through, kind of filter through, and still have a lot of shade on the glass, almost always, in a way that you can prevent indoor glare problems. This is a very interesting building we've been now starting to build. We're almost up here with the concrete construction. It's a 4-star hotel, and in this hotel we were able to use a lot of the ideas we've developed in the past years in the office. Our idea that building should be more like an ecosystem. In this building, we were able to kind of close the cycles of water, CO2, waste, and energy up to a very high level. And we were able to do this by the use of a greenhouse system, a kind of biomass installation. And all these elements work together to kind of reduce the output of the building. So you reduce the amount of waste, of water, because inside the building you can reuse a lot of this. Also the facade design, which you saw in the previous picture, is a big part of the energy use. Of course, a hotel is only used in a very small time span by the guests, and a normal hotel the installation would go on and on and on to cool the buildings for the moment the guests arrive. What we did here is we made a dynamic facade, a facade that sees where the sun is, that knows where the sun is, and then determines for itself if it needs to close to kind of insulate the room, which are kind of insulating panels, so to block the sun, or maybe in winter time it kind of opens the facade to let the sun heat inside to heat the room in a natural way. And that was all the kind of research we did together with our installation advisor here. And you can see that when we use this is the final solution we're now working with. These are reflecting aluminum insulated panels, and you can reduce the required amount of cooling to 99%, so just a fraction of the cooling you need, and also the heating is reduced greatly compared to if you would make just a glass facade. And this is the facade. So what will happen? We are very enthusiastic about this building, and we've made the mock-up of one room, and it works quite well. What will happen is during the day, the sun will go around the building, and the building will decide for itself on each facade to close or open. Of course, a guest can override this system and can open the facade for itself. A build in Holland, I would like to elaborate a little bit more on this project, because I think in this project a lot of our ideas about healthy buildings, about energy efficiency have come together. It's a collaboration we did with Arup, which has also a climate department, and well, it was a really nice collaboration. This is a primary school. In Holland, we have extremely low budgets for primary schools, which is about 1,050 euros per square meter, which is really, really difficult to make a good school. Here we got some extra budget to make a sustainable school, but still, you really have to work with the money. It's just a bit. So what we did is we were able to find a piece of land that had a lot of ground floor level. So of course these are young children. You would like to have them on the ground floor as much as possible. We created an indoor schoolyard, which is kind of protective and is the heart of the building. And on the front of the building, facing the new development, the new housing development here, you have the sports and the gym here. So it's sports and the big gym volume there, and the older children are also on the roof, and they can use the roof inside the garden and on top of it as a kind of a schoolyard. And of course they can play outside in the woods when they're older. What we did here, we really thought it would be difficult within the budget to make it possible, but it worked. We had a very far integration between architecture, construction, and the installations. What we did is we made a total construction of wood, so with columns, beams, and sub-beams. We used the spaces between the sub-beams as a air duct, and so that the air kind of goes from this facade, passes in between this space, and then falls into the building, climatizing it. And on 2 points, we kind of pull out the air, and this makes a very slow but good airstream, because you have a really high amount of air and low speeds. Then you're assured not to have too much CO2 in the classrooms. On top of this, we have a wooden deck. And on top of the wooden deck, we have a thin concrete layer with floor heating and cooling, top cooling. And on top of that, the gym, which is made out of a steel construction because of the acoustic of it. If you play basketball here, you don't want to have the young children bouncing around all the time, of course. And it looks a bit complicated, but this is a system we've been working on with Arup together, and it's now finished. What you see is the dark blue beams are the air inlets here, and air is pulled inside the building, and in this beam the air falls into the classroom, and is then pulled out of the classroom here through a kind of a box. I'll show you a picture later. And on 2 points, that point and that point, we are with machines, air machines, we're pulling out the air. And because you know the exact amount of air you're pulling out, you know you're sure to have on all points the air coming into the building. So looking into the building, this is of course very much a kind of technical approach, but of course it's also a really nice, really nice, healthy building with a wooden construction. So this is the wood construction. Then you have the box, so you get the air from the outside. We have a heating element here, which is connected to a heat and cold storage into the soil, and climatizes the air a bit. And then the air goes into the spaces, and then climatizes space and is pulled out into the more central spaces in the building. And this is the way it works. So we have on the far left a kind of screen facade which blocks out the hard winds, and is very open for air to go through. And air goes through these ducts like this. These are ventilation elements. This is a heating cooling element, and then air falls through into the classrooms. And it kind of gives you this quality of indoor spaces. What we really like about it is that children can see how a building is made. You can see, oh, it's a column, a beam, and that beam. And suddenly you don't have all these lowered ceilings anymore. These are the ceilings where the air falls through. But you have a very high, airy building. And we use the concrete floor here, which is it's a bare concrete floor, but then polished and with a thin coating on top of it for heating and cooling. So children, of course, they sit on the ground a lot, so you also need this comfort. And here you can see the inside space, the schoolyard. You can see the children sit on the floors a lot. This is not the common Dutch school where you have the classrooms, of 56 square meter. But here the children are. It's more kind of a free school where they live around in the building, and well, it's a really happy school. The outdoor space is just finished. We still need the green to go in here. And here you can see the facade of the building. So this green facade, the forest around it still has to be planted. So it's a kind of a barren land now. But here you can see the green facade, which is kind of the windshield. And all these vertical and horizontal seams are points where the air can go through the facade and into the ducts to kind of climatize the building. And the plinth of the building, the ground floor layer, is made of a combination of wooden planks and a lot of glass. I would like to close off with a project we did for TNT. The previous project was much more about healthy buildings. For us, this is also an interesting building because it's about zero energy and what do you need to do to make one building zero energy. Of course, for us this is a case study. It's not, we don't have the feeling that you should do this everywhere, but for one building it's quite interesting. We went for a LEED Platinum building here, operate and maintain, and a green calc is a way of calculating the sustainability in the Dutch system. We made a building of about 18,000 square meters with a central atrium organization, which also makes that you have quite a compact building envelope. So the heat loss is quite low. You have also, of course, when you want to go to zero energy, you have to make sure that you don't lose a lot of energy, as we heard before. And the next step is to find out how you can produce the remaining energy, and it's quite shocking how much energy you really need. So together with an installation company, we made this machine. We call it the green machine, and it's a bio installation which uses fat from the surroundings. So it's from the where you fry or make your fries in. Well, we collect it. It goes into the machine. And there is a lot of energy in this, and we can produce a lot of electricity and heat. The heat goes to another project, so it goes to the left. And our building needs a really large amount of electricity, but in this way the building is totally detached from the electricity net. It's been interesting. Also, there has been a lot of going back and forth into the system in ways of operating it. Of course, it's quite difficult to operate a machine like this. It has broken down a few times, but they kept it going. And the machine is also kind of an architectural element. We wanted people to be able to feel the machine, the green machine, and say, okay, this is where our energy comes from. So what we're looking to is changing kind of the top-down energy system we have now. The big coal power plants in Holland, we still use a lot of energy from this, to going towards a situation where buildings can produce a lot of their own, maybe not everything, but a lot of their own energy. That was my story. Thank you very much.
Jonathan, your final scheme, the big housing estate, I think was it in Hertfordshire? Herefordshire. And you said that you used a decreased density on the site in order to work with your passive house ideals and stuff. But what would be your thoughts at the moment in the UK that, ignoring developers' viability, etc., that we have quite spaces at a premium as well? Would the same kind of things work on denser sites, using the sites more effectively? How much percentage loss of units would you get doing a scheme in the way that you did?
We're only proposing low density there because it's a rural setting, and we feel that it's appropriate to design in tune with the densities that exist in a rural area. But also when you're doing sort of simple two-storey buildings, they're less efficient in terms of energy. So it's more important to keep them simple and make them more affordable. If you're doing an urban scheme, then you can do much higher densities. The scheme that I showed a brief picture of in Chester Belmore in Camden is very high density. And you actually then get the benefits of the efficient form you get by putting 10 or 20 or 100 flats into one unit, because you get less surface area for the internal residential area. So passive house can work at high or low density without any problem whatsoever. And in some ways, a tight, urban, dense site is probably the most efficient way to do passive house. What we're just trying to do is develop the right model for each setting. So a rural site, make passive house efficient by making the form simple and doing it at low density, and a tight urban site, go to much higher density and make it work that way.
I heard a lot about passive house as a sort of holy grail. I was hearing recently, though, that there are some viable objections to that in terms of, if you stop all keep all the air in, is that storing up problems for the future, whether that's health of people, of the inhabitants, or actually the health of the materials that are in the building? Because people and materials are used to being in an environment where there is an airflow, constant airflow and constant change in temperature. But if it's tightly controlled condensation and other issues, what are your thoughts on that?
Actually, I think there's a sort of myth that you get less ventilation in passive house than you do with normal buildings. In fact, you get more ventilation, and you actually get properly designed and controlled ventilation. So with increasing energy efficiency, all buildings are having to be built to higher standards of air tightness of the fabric. And so you're getting rid of the accidental loss of air through the fabric, which is bad in terms of warm, moist air condensing within the fabric, etc. But once you get better air tightness, you then need to actually do ventilation properly. And under building regs, the way building regs works, say in residential, is extract fans in bathrooms and kitchens and trickle vents over windows. It's not designed, it's completely random. And so sometimes you get good ventilation, sometimes you don't. And because you get cold areas where there is thermal bridging, you get condensation, and people turn off the noisy vents in bathrooms, they don't like them, they tape up the trickle vents because they don't like them. Whereas with passive house and mechanical ventilation, you get constant supply of fresh air. It's actually bringing fresh air from the outside all the time, extracting the stale air constantly and transferring the heat between the two. So you're actually not keeping the air in, you're constantly changing the air with fresh air from the outside. So what you basically get is guaranteed good air quality, without the problems of drafts, and actually also eliminates condensation because you're taking out moist air constantly. So one of my colleagues who moved recently into a passive house building was amazed that he could do his washing, hang it up on a rack in the evening, and by morning all his clothes were dry and there was no moisture in the building because it's all been taken away all night long. So I would say quite the opposite to the implication of your question. Passive house guarantees good air quality, good air movement, good ventilation, and that actually is healthier. In Germany, there's a lot of evidence in our own schools, evidence that children with asthma actually have less incidence in a passive house building because you're getting rid of a lot of the pollutants and causes of asthma.
I'll throw a little bit of a spanner in the works, because one of the things we've got today is we've got two great designers who do really beautiful passive housing. But if you type in passive house or Code for Sustainable Homes into the internet and you type in the word beautiful, they're all very cuboidal forms. And one of the key issues, and it's driven by who potentially the client is. If you've got a housing association, then they're driven by certain criteria. So they'll say follow a certain benchmark or follow a certain type way of designing. And the benefit that we sometimes have with our private clients is we'll say, well, what's the best common sense approach? So there's certain aspects of passive house which are very intelligent. There's some things of Code for Sustainable Homes which were very intelligent, but there's some things which are a little bit silly as well. And as a designer, ultimately who are we designing for? And therefore, if you are in a position to change the best parts, and as the industry and the RIBA, I think, have a responsibility to say, well, let's perhaps formulate a hybrid of these, then we can get things whereby on a passive house you get certain points for how beautiful is it. Because at the moment we're starting to get a scenario where it's about the smallness of the envelope, and we're getting to a point where we've hit a ceiling really in terms of what those houses can do in terms of their aesthetics. And if you spend 60-70% of your time in these buildings, you need to make sure that there's other qualitative aspects there as well. So I'd like to get your view, perhaps from a Dutch perspective, what you're feeling, because we do a lot of work in Holland as well, and there's a different mindset in terms of what makes a good building in terms of health and the amount of time you spend there, rather than just, economic or energy parameters.
The point is, if maybe on the previous statement, that you cannot have one solution for all kind of buildings. So passive house, I think you have to approach each building in its own perspective, in its own location. If it's urban density or it's in a kind of a rural environment, if it's a school, an office, or a housing, it also makes a big difference, the amount of people that are inside a building. Every time you have to see which elements you take in and which elements you take out. In Holland, energy efficiency has been promoted by the government for a big deal. That we have the energy performance norms from the government, which have been sharpened this year, also 50% lower. So we are now going down with housing to a level in which you have to almost everything has to be energy neutral, and the government is approaches it quite in a technical way, but. It's interesting that sustainability also for the government is a big political thing.
I have to just jump in and disagree. I think there are, of course, examples of boring, bad passive house. There's also hundreds of examples of boring, bad, non-passive house, and I think it's incorrect to assume that because it's passive house, it's not going to be that great. I mean, good design is in the hands of designers. And whether you're designing passive or non-passive house, it relies on good architects. I'm sure you'd agree with that. We both agree with that. I passionately believe in good design. And for us, passive house is simply a tool to enable us to make sure our buildings work. And we can design exciting, innovative, unusual, beautiful buildings, but we know they're going to work. And I think one of the things I would argue for is that our industry is absolutely terrible at ignoring the performance gap between how much energy buildings should use and how much they actually use, and nobody's really tackling that. For us as architects, doing it to passive house just gives us the tool at a design stage to ensure that whatever we design, it's going to work. And I think that actually frees up our creativity rather than restricts it, because we can do anything we want then, but we know that as we design it, we're testing it, and it will actually work. So we can design a great, beautiful building, but it will work for comfort and it'll work for energy. I think that is what I would argue. But of course, there's bad passive house out there designed by poor architects, but there's huge amounts of poor buildings that are non-passive house designed by architects as well. So good design is important, but I think also efficiency is just part of good design.
My question goes to the last speaker. When you were talking, you were explaining things. I saw a radial graph when you aggregated some parameters and you put aesthetics in. I just want to know how you were able to quantify the degree of aesthetics in the graph you showed.
It's always difficult to quantify aesthetics, of course, but what we want to say with this graph is that as an architect, you should approach a building from much more points than only the aesthetics of a building, and that you can use things like passive house or energy neutral buildings. You can use it as tools to make better architecture. That's what we try to achieve with our clients.